Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. Okay, today we try to understand the Newton second law and then the concept of the equilibrium of the forces relative to the inclined plane here. Okay, so start. Object is moving downwards, so with acceleration A. So this means from the inclined plane, so the object is moving downward. So for example, so here is the inclined plane. So then they may angle the theta to the horizontal. So here is the horizontal. And then this one is the inclined plane. Then the object with the mass m kilogram here is moving downward. So with the acceleration A. Then today we need to understand how we can use the Newton's second law to solve the problem. So we continue. Okay, so we continue. So object is moving downward with acceleration A. So from the Newton's second law, so the resultant force is equal to the mass times the acceleration, or ma. So if the object is moving with the acceleration, so that's mean we refer as a dynamics. So this means in the chapter dynamics. So actually what is a dynamics? So dynamic is we study the motion with the force. Okay, so saya study di sini. So study the motion. So with the force. So with the force. Okay. Then before we continue, so there are the important notes here. Okay, so in order to solve the problem in the dynamic, so we normally we use this concept. So we have the force, and the force is same direction with the acceleration. Then we take as a positive. If the force in the opposite direction with the A, so we take as a negative. Okay, so and then we can refer to this diagram. So here is the direction of the A. So from the right to the left, for example, and then we have the two forces here, F1, and then we have the F2. F1 is a same direction with the A. We can saw here F1 is same direction with the A, so we take as a positive. And then for the F2, so very clear here, so the opposite direction with the A, so we take as a negative. Okay, so because we apply this concept, so no need for us to use the free body diagram. Okay, so we continue. So and then if the object is stationary, so this means the object is not moving in the inclined plane. So and then what happened? So of course the resultant force is equal to 0. The resultant force is equal to 0. That means the total of the force to the component X is 0, and then the total of force to the component Y is 0. Okay, So for the equilibrium of the force, so normally we use the free body diagram. So our free body diagram is we apply to this positive x is here, and then here is the direction of the positive y. And then so for the force, for example, we have the force F1. F1 is to the right, F2 is up, F3 is to the left, and then the F4 is downward. Okay, so for the apply free body diagram, so we can saw here F1 is in the positive x, F2 in the positive y, F3 in the negative x, and then the F4 in the negative y. Okay, so and then for the equilibrium of the forces that means the F1 is balanced by the right is balanced to the left lah. So that means the F1 is balanced to the F3, and then of course the F2 is balanced by the F4. Okay, so clear. Okay, so we continue. So and then we refer to the free body diagram. Free body diagram pula. So we refer to the inclined plane. So because we focus on the inclined plane, so we need to understand so the dynamic and then the static for the inclined plane. So object M is moving downward with the acceleration A. So from this diagram, what we can saw here is the mass M. The object with the mass M is moving downward. So in this case, we can draw the direction of the A downwards. So and then, so because this is the rough surface, so and then for the rough surface, that means we have the frictional force. Okay, so here is the frictional force. Okay, because the object is moving downward. So if the object is moving upward, so the frictional is the opposite direction of the motion. Okay, so we continue. Understanding the frictional force Fg. So Fg is mu r. So what is a mu? Mu is the coefficient of friction. And then r is the normal force. And then r is here. Is a normal force to the surface. And r, of course, is balanced by the r is equal to the mg cos theta. Okay, so before I continue, so I need to explain the weight of the object. So in the inclined plane, so first thing we have to do is to resolve the weight of the object to resolve to this here, to this direction mg cos theta, because this one is the theta. Then of course we can prove the theta is here is theta lah. The angle here is here theta. So mg cos theta, and then we resolve to here, so we have the mg sin theta. So that means mg cos theta is the component of the weight of the object. Same with the mg sin theta. Mg sin theta also the component of the weight. Okay, so then we can get the frictional force as a mu mg cos theta. Okay, so then we continue. So we apply the Newton's second law. Resultant force is equals to the ma. Fa is the resultant force. So then we have to refer to the notes, the last note. So if the force in the same direction with the A, so in this case is mg sin theta is here, and then the same direction with the A, then we take as a positive. and then FG is opposite direction of the A, so we take as a negative, and then is equal to the MA. Then we have the mg sine theta. We continue. Mg sine theta is minus FG is here. Then we have the mu mg cos theta is equals to the MA. So when we have this equation, so we can solve the problem. It's up, depends on the question. Either to find the mu or either to find the acceleration of the object of the mass. Okay, so we continue for the if the object is stationary. So if the object is stationary, that means the A is equal to 0 because the object is not moving. So in this case, so the inclined plane, so we solve the component of weight to here, so we have the mg cos theta, and then we resolve to here, so we have the mg sine theta, and then equilibrium of forces, so that means the object is not moving, so up the R is balanced by the mg cos theta, so you have the R is balanced by the mg cos theta. This R is balanced by the mg cos theta, and then the mg sin theta is balanced by the frictional force. So we refer to here, so R equals to mg cos theta mu R, so we have the frictional force. And then because the object is stationary static, so we have this resultant force is equal to 0. Therefore you have the mg sin theta minus Fg is equal to 0. Mg sin theta balanced by the Fg and then equal to 0. Then you can manipulate the equation mg sin theta minus mu mg cos theta because Fg is here. So and then you manipulate the equation, and the last we have the equation mu is equal to the sin theta equal over the cos theta, and then is equal to the tangent theta. Okay, so actually is a comparison between the moving object in the inclined plane, and then if the object is stationary in the at the inclined plane. So I give you the example. So in this case is the example. So we have the object here, and then the object is moving downward with the acceleration A, and then they ask you to find the A. So because the plane is a rough surface, that with the coefficient of friction is 0.3, then we have the R is here is balanced by the R is balanced by the mg cos theta. R balanced by the mg cos theta, so we can get the 42.48 Newton. Then we have the frictional force mu R 0.3, 42.48, and then we have this 12.74 Newton. So we have the frictional force. Okay, then so force, so take notes, force in the same direction with the A we take as a positive. So in this direction of the A is here, so the force in the same direction with the A is the mg sin 30 degree. So we have the 24.52 Newton. So it's a mg sin 30 degree positive minus the Fg negative, opposite direction of the A. Then we can get this 11.78 Newton. And then we have the resultant force, and then we apply the Newton's second law, and then we can get the 2.36 meter per second for the acceleration of the object. So object is moving downward with the acceleration 2.36 meter per second. Okay, so in this case, just to summarize here, So if the force in the same direction with the A, take as a positive. And then if the force is a opposite direction to the A, so we take as a negative. Here is a positive force, here is a negative force. So, and then hope we can understand how to solve the problem in the inclined plane. Okay, for that, thank you.